We didn't formally address it. Molecular formula versus empirical formula. We said empirical formula is just the simplest ratio. So ionic compounds, the formula you have for an ionic compound, is always empirical. But in a molecular compound, you can have something that's more than the simplest whole number ratio. And we talked about sugar, glucose, C6H12O6. And we looked at some examples where C6H12O6 is the molecular formula, but its empirical formula is, CH2O. And we could have a bunch of molecular formulas that meet that same empirical formula. So C3H6O3, C20H40O20. Those all have the same empirical formula. Okay? We very often get empirical formula. You find empirical formula when you're given percentage comp information, and you will want to practice those, I can guarantee. But now we're going to start to look at what happens if you're given the empirical formula. Can you find the molecular formula? You can. There's a way to do it. You probably guessed that, or I wouldn't have said anything about it. So we'll see. I think I have double of that. Okay. There are two slides on this topic because I think I rearranged them over the years. So the molecular formula is really just the empirical formula times some number x. Okay. And if we look at the example of glucose, C6H12O6 is the molecular formula, and its empirical formula is CH2O. If we multiply every one of the subscripts in the empirical formula by some number, we get the molecular formula. Okay? And in this case, the number is 6. So if we multiply the entire empirical formula, the subscripts obviously, we get molecular. Well, what that gives us is something that we can actually rearrange to solve for different things. So we can solve for the multiplier. We can solve for the empirical, we can solve for molecular formula most commonly. But there's a problem. So what we have to do is we have to translate that into mass. Let's look at one more slide, and then we're going to do some examples. Okay. I think I still need to clean these slides up a little bit. Yeah, let's just go with this. So, to make it as simple as possible, the molecular formula equals x times the empirical formula. The molecular mass is also equal to x times the empirical formula mass. Okay? Or we could just say the molecular formula mass. There. Now, these are numbers that we can get readily. We have ways of getting this information. We can figure out what the molecular formula mass is or the empirical formula mass. So we keep using C6H12O6, so let's stick with it. Let's use glucose. So what's the molecular formula mass of glucose? So we've got C 12.01 times 6, H 1.01 times 12, O 16 times 6. Who's got it so far? Calculators. You didn't sit down without a calculator, did you? 180.18. Okay. That is the molecular formula mass for that compound. Now, the empirical formula, CH2O. What's the empirical formula mass? We've got 1 carbon, 12.01, 2 hydrogen, 1.01 times 2, yeah, I started to shortcut it. 16, so what do we get for empirical formula mass? 30.03. And I'm being very, very sloppy here with my units. Of course, this would be grams per mole, and this would be grams per mole. So let's try something, shall we? Let me move a few things around here. Okay. So we're asserting that the molecular formula mass is equal to some number times the empirical formula mass. We said, I mean, looking at this visually, we know that if we multiply all the subscripts in the empirical formula by 6, we get the molecular. So go ahead and solve for x. Divide both sides by 30.03 grams per mole. That makes this go away. Cut. What do you get? X equals? That's so weird! Pretty slick, isn't it? In essence, yes. In essence, yes. And we call it the whole number multiplier typically. The way these problems usually come to you, you're given an empirical formula, you're given a molecular formula mass. You have to figure out the molecular formula. So let's do an example together. Okay. We're told that it's got an empirical formula of C2H3O. We're told it has a molecular formula mass of 172.2 grams per mole. What we want to know is, what's the molecular formula? How do we get started on this? We need to figure out the empirical formula mass. So we know that, I'm going to abbreviate this, molecular formula mass equals X times the empirical formula mass. Well, we have this. We need that. That's easy. Carbon is 12.01 times 2. Hydrogen is 1.01 times 3. And oxygen is just 16. No? 43.05? I was going to say, I think you missed a carbon atom. 43.05 grams per mole. Well, we know that whatever the molecular formula mass is, divided by the empirical formula mass, that will give us our multiplier. So, 172.2 grams per mole divided by 43.05 grams per mole equals X. What is our whole number multiplier? Yep. I had to check. I made it up, but I was thinking 5, but no, it's 4. You're right. So what's our molecular formula? What are we going to do with that 4? Yep. Each of the subscripts is untight. So that means 2 times 4, 3 times 4, and 1 times 4. So what we get is C8H12O4. Okay? Fairly straightforward? Okay. Do you know what would be really mean and nasty and evil? I'll tell you what would be mean and nasty and evil. If I gave you a problem where you had, I gave you percent comp information, like it's 12% this, I'm pulling these out of thin air, I don't know that they add up, and whatever, squiggle percent that. So you had to find I gave you that, and I gave you the molecular formula mass. What would you have to do? Oh my God, that's evil! Would I do that? Yeah, of course I would. You'll have one on your test. Promise. I think there's one in the homework like that too. So here's what I'm going to do. Homework is due tomorrow. I'm going to have a paper-based FIP quiz for you on finding empirical formula from percent comp and finding molecular from empirical. Because you're in the unfortunate position that your study hall is before your chem class, what I want you all to do is come down here tomorrow and pick up that FIP quiz, go take it in your study hall. Okay? I will have a key in the hall. It'll be like a kind of an on-your-own FIP again, not where we take a whole class period. I'll have a key in the hall, and you check your own stuff. Monday when you come in will be your multiple choice test over this chapter. Tuesday when you come in, we will allocate one period for a workout test. After that, you'll have a what do you know about chemical reactions, and you'll get started on doing a close reading for the chapter, and then we may or may not get to start notes. We'll see what happens. We'll see where we go from there. Yes, sir? Your next lab, we do a couple labs in Chapter 8, and we do 3 labs in Chapter 9. We did not do a lab in this chapter. Is that what you were noting? Like, hey, it's been a while. There are a couple different ones that we do in 8, and I can't remember which one I typically do first. So we do a bunch of neat stuff. The soap lab is coming, though. You didn't like the soap lab? Did you give your soap as a gift? Record this for posterity. This is a hint on, what number is it? 30, I want to say 37 or 38 or 39. CuSO4 5H2O. Which one is it?
It's 35.
Oh, it's 35. Okay. Clue on number 35. So is it CuSO4 5H2O? Okay. This is a kind of compound that's called a hydrate, and what it means is that this copper sulfate, as it sits, absorbs water. So for every 1 unit of CuSO4, you end up with 5 molecules of water absorbed onto it. So it doesn't form a compound, that's why it's shown like this. But if you're thinking about percent by mass water, you can think about it like that. Okay? And you can figure out what's the mass of this whole thing, and then what percentage of that is water. Okay? Other questions, comments, or concerns? I can't, somebody asked about tutoring. I can't stay after tonight, but I can stay after tomorrow, and there is that second period study hall tomorrow. So if you're stuck on something and you need to come down, you can. That's it. Anything else? Questions, comments, or concerns? Okay.